All right, this is the last video, video 4 for lesson 3.9 on systems of equations. And we're going to look at this last example, example 4. You're running a company that makes and sells teddy bears. You spend $500 for equipment, plus it costs $3 per bear for the materials. You are selling the bears for $10 each. How many bears must you sell before you start making a profit? So we have two equations. We have the cost and we have the income. So this one will be a little bit different in that when we think about the cost, $500 for just the equipment. So that's like sewing machines and needles and the things you're going to use to make the bears. And then there's also a cost for the material. So you got to whatever the bear is made of and the stuffing and all that kind of stuff. So in this case, this is our start value. We start at a $500 cost before we even make a bear. Maybe that's the sewing machine. And then it's $3 per bear. Once again, when you see that per, that's a good indicator that that is a rate of change. So that is our rate of change. So for this first equation, it's going to be $3 for every x. X is the number of bears. And y is going to be money. Now, I want to be real careful with that because there's money in and there's money out, right? There's money that you are spending and money that you are receiving. So this y is money that we are spending. So it's $3 for every bear plus the $500 that you started with, right? So it's $500, and let's go right to the table. If I don't make any bears, I've spent $500 for the equipment. If I make one bear, that's going to be $503. If I make two bears, that's going to be $506 because every bear I make costs $3. So 3, 4, 5, that would be 509, 512, and 515. Now this is our income equation. We are selling the bears for $10 each. That is a rate of change. I want to be careful with this because I know we said per is a good way to indicate that it's a rate of change. It's not the only way. Sometimes we just have to think about what's happening in the problem. Is this a one-time thing, or does it happen over and over again? If it happens over and over again, it's a rate of change. You get $10 for each bear. So it happens again and again and again. At the beginning, if you have sold 0 bears, how much money have you made? That makes sense, you've made 0. If you sell 1 bear, you've made $10. I want to be careful. You've received $10, not made $10. Because remember, you still have the costs that we have to consider. If we sell 2 bears, that means you've gotten $20 from that. 3 bears is 30, 4 and 5 is 40 and 50. Now, the question is, how many bears do you have to sell before you've paid off your expenses? Because remember, if you sell zero bears, you're $500 in the hole. If you sell 1 bear, well, you've spent $503, but you've only received $10. So I think that puts you at $493 in the hole. So you still haven't made money yet, right? So as we go down the table, the amount that you owe, that you're in the hole, it goes down. And at some point, you're going to start making money. When is that? Well, you could keep extending the table until these numbers match, until the number you spent is equal to the amount of money you received. This seems like a very long process. You're going to have to do a lot of rows to get down there. Seems like a lot of work. The graph. I don't think the graph is a good method yet. It's not the way to go. Because, once again, I don't know what scale to put in. I have no idea when the intersection is going to happen, when the two lines meet. So this is really the best way to go. So let's write our two equations. Y equals 3x plus 500. That's the cost equation. And y equals 10x is the income equation. I forgot to write the income equation over here. I apologize. We talked about this being the rate of change, but I never did write the equation. This is 10x plus 0, because you don't get any money at all. There's not like a starting amount of money you're given. So you have 0 profit to start, and then you add 10 for every bear. So I'm not going to put the plus 0 here. It's not necessary. But let's go ahead and solve the equation. Now remember, this is the equal value methods. What we're saying is when the cost and the expense are the same, these should be equal to each other. And then which one do I put on the left side of the equation? It's better to put this one over here, the 10x, and put the smaller one over here, 3x plus 500. And I'm not looking at the 500, I'm looking at the x terms. If I don't want negatives, when I flip this over here, this is going to give me a positive 7x. If I were to reverse it and I flipped this to the other side, if I flip the 10x over here, if this were reversed, I'll just write it over here. If I did 3x plus 500 equals 10x, if I flip this over, I would get a negative 10x. And I flip that over, I'd get a negative 500. That's a lot of negatives, right? This is a war, and the negatives win this war. Do you see how I have negatives on both sides now? This isn't wrong. This still gets me the correct answer. But you're dealing with a lot of negatives you don't have to deal with if you just put the bigger one here. I'll continue to solve this. So we flip the 3x to this side. It becomes negative 3x. Oops, I forgot my x. 3x, 10x minus 3x equals 500. Then we fight the war, positives win, and then our last step is the division. So divide both sides by 7. This is a calculator moment. So I'd get the calculator out and do the division. I might be able to do, let's see, 50 divided by 7 is 7, that's 49, which leaves 1 left over, so that's 10, so that goes in 1 time, and that's a 3, drop a 0, that's 30, that goes in 4 times, I don't know, I'm going to do them. Let's grab a calculator real quick. Sometimes at the end of the day, math in your head is hard. So 500 divided by 7 is 71.4 whatever. 0.428574143. So I'd say about 71 bears. Teddy bears. Let's be specific. Teddy bears. So that's about when you're going to start making profit. It's a little bit after that, right? It's not exactly 71, it's 71.4. So at 71, you're not making a profit yet, but you're really close. At 72, you will be making a profit. And so for this one, it's kind of, I don't know if there's an advantage to plugging this number in to the equations, other than I could go right to, this is a nice super easy equation, right? If I plug in, if x equals 71, then 10 times 71 is equal to 710. That's the amount of money you would have received, right? If I do it in the other equation, which is 3 times 71 plus 500, that would be 3 times 71, using the calculator, is 213 plus 500. That's going to be $713. This is how much you spent. This is how much you've earned. So you can see you'd still be $3, because remember, this is spent, this is earned. You would still be $3 short, right? We knew 71 is not the answer, it's 71.4. So we would still be $3 short. So we'd still be we would have negative $3. But what if x is 72? Well, with the first equation, we would make $720. That's how much we received. That's our income. And if this was 72 plus 500, that would be $216 plus 500, which is $716. Now, that's what we spent. Sorry, I gotta move that up. That's what we spent. That's what we brought in. Now, you have $4. Now we're making money. We have profit. And so we could see that where it zeroes out, where they're exactly equal, is 71.4. But that doesn't make sense because you can't make this many bears, right? You can make 71 or you can make 72. So in order to start making money, you have to sell 72 bears. Now, what does that look like graph-wise? Well, now I know my graph has to go up to 71, and my money has to go up to 700. This graph is going to be harder to graph. I can go the same way I did before with 10s, 20s, 30s. 1, 2, 3, 4. We'll go by 10s. $90, $100, $110, and $120. Okay. And then money-wise, I need to get up to around $720. That's going to be real tough to do on this graph. I could go by 50s. I think I would go by 50. So I would make this 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. So now I have values here, but once again, this doesn't fit really well. The intersection's supposed to be around 71, 72, and we don't know exactly what that amount is. I probably wouldn't use this as one of my points. Now, we do have the table from the previous page. We could put 0, 500, and 0, 0. So we definitely have, this is our expense. We start at 500 for the expense, but what are we spending? We're spending $3 every bear. So I need to really find a good way to get another point here. And one way I could do that is just start picking numbers, right? So I know it's 3 times something. Well, what if I put 3 times 20 plus 500? Is that a good point? 560 doesn't work really well, does it? How about 3 times 25 plus 500? 575, that might be a little easier to graph. If I go 500, that's 550. 575, that's not bad. I could go out to 25, which is here, and do a 575. I still don't like that point because it's not exactly on the grid mark. So we could just keep trying other values. What about 3 times 50 plus 500? 650. That's a great point. So if I go to 50, here's 600, here's 650 right here. That's a pretty nice point. I bet you if I put in 100, that would work really well too. 3 times 100 plus 500 would be 800. So if I do 100 bears at $3, that's the cost. It cost me $300 plus the original 500, that's 800. So I could go to 100 and 800, which is right about here. And now, so you don't have to do every single point. Sorry about that. I think this was all scooted up. you could just plug in different values and you could pick nice numbers on your scale here and just keep doing them until you find some that work. Do all of these line up that I put on here? Well, there is the 100, 800. That looks good. Does it line with the other ones? There's the 50, 650. There's the other 25, 575. I mean, they all do line up. And then there would be my expenses. And that is line y equals 3x plus 500. My income line was just 10x. So that one's pretty easy, right? If I put, well, so we start here at 0, 0, right? If I have 0 bears, that's $0. What if I did 10 bears? So 10 times 10, that's 100. So at 10 bears, that's 100. At 20 bears, that's 200. At 30 bears, that's 300. So I can already see this pattern going across. Once you've established it, you can just keep going all the way across the grid. Well, that's nice. And now I'll just continue, connect those dots to the very beginning. And that is the income. That's the money you have coming in, and that was just y equals 10x. Now look where they intersect at. There's 70, somewhere around 71, and if I go over here, it's a little bit over $700, both for the expense and the income, right? So that is where we call the break-even point. So break-even points are really important in business because you want to know when you start making money, right? You get into business to make money. And so once your income is greater than your expenses, remember this is your expense line. Once this income line is above the expense line, that means you're making money. If your income line is below your expense line, then you're not making money. And so this lets somebody know if they were planning on opening a business, like how many bears do I need to sell before I can start making money? If it's 71 bears and you don't think you can sell 71 bears, that's not a great business. You probably shouldn't do it. But if you're confident you can sell well over 71 bears, then you can make money, right? And every bear after that is going to be profit. Obviously, you still have a $3 expense, but you'll be making $7 every bear after that. All right. Well, that is the end of that lesson. I'm all out of notes. And that was the last lesson for 3.9. So the next things that you're going to be working on is your project for this chapter and your test for it. So, yep, that's it.